Hi, welcome to Photon Academy. In this session, let us see some more problems appeared in the JEE examination. Let us see one by one. The first problem I take up is the dimension formula of into epsilon into E square, comma, where epsilon is permittivity of free space and E is electrical field. Electrical field. Yeah. This was the question asked, and this was appeared in the JEE exam. He is asking the dimension formula of this quantity. Clear? Now observe here. He has provided 4 options also. Those options are right. First one is M L T minus 1. Second option is M L square T minus 2. Third option is M L minus 1 T minus 2. Fourth option is M L square T minus 1. Clear? These were the 4 options provided. Now, what does he require? He required the dimension formula of into epsilon into E square. Look at this. This of does not possess any dimension formula since it is a number. So we require only the dimension formula of epsilon into the E square. Clear? Now, if I know the dimension formula of epsilon directly and dimension formula of electric field directly, I can easily substitute and arrive at the solution. Clear? But in order to know the dimension formula of these, I have to go through the fundamentals. Clear? Now let us see. Epsilon. What is epsilon? Yes, given that permittivity of free space. Recollect the previous session. In the previous classes, we have seen that the force of attraction or the repulsion between two charges, electrical charges, is given as 1 by 4 pi epsilon into Q1 into Q2 divided by D square, where Q1 is one charge, Q2 is another charge, and D is the distance between them. Observe, if I represent it, let us say this is the Q1, first charge, and this is the Q2, second charge, and the distance between them is D. Then the force of attraction between Q and Q2 is given as F. and where E naught, that is epsilon, is the permittivity of the free space. Clear? Now, observe here. In this case, these 4, 5 do not have any dimension. Hence, if I simplify this, f is equal to 1 by epsilon into q1, q2 divided by d square. Observe, I require that epsilon, which is after rearranging the terms. This is one charge, this is another charge. So both are charges. So if I represent it as q, and it has also q into q, q square by. Observe, this force is coming over here, and this force into e square. So this is the required formula for the permittivity of the free space if you do not know directly the dimension formula of it. Clear? Now, observe, we require the dimension formula of epsilon into e square. Since of is a number, we have deleted, we have omitted it. So observe, I am substituting. Epsilon is what? That is the q square divided by f into e square into electrical field. What is the definition of electrical field from the fundamentals? It is electrical force per charge. Charge is q. Now, since it is a e square, here it is e square, so entire thing is, that means q square by f into e square into f square by the q square. So on simplification, this q square goes, denominator f, one of the f goes, remaining term is f by d square. Clear? F by d square. So finally, it becomes f by d square. What is the dimension formula of f? Force is what? mlt minus 2 by d square is what? Distance, l square. So m l minus 1 is l, one of the l goes out, t minus 2. So final dimension formula of the of into epsilon into e square becomes. So in the previous options, option C, ml minus 1, t minus 2, C is correct. C is the correct option. Clear? Now, let us see another problem. The second problem is, which of the following have different dimension formula? Okay, this is the question given, and options he has provided. First option he has given, pressure, Young's modulus, and stress. These are the first option. The second option he has given is EMF, electromotive force, potential difference, difference electric potential. This is the second option he has quoted to you. The third option he has given is 8 work done and energy. Okay. Now, the fourth option quoted is electric dipole moment, comma, electric flux, and third one he has given is electric field. These were the options. And this was also a question appeared in the JEE. Now observe carefully. He is asking the dimension formula of those physical quantity which do not have same dimension formula. Underline the word. Do not have the same dimensional formula. Clear? Now let us see the one by one. Let us check up one by one option. First option, what he has given? Pressure. What is pressure? Normal force by area. What is dimension? M, L, T minus 2. Force is area is L square. So M, L minus 1, T minus 2. Force by area is the dimension part. What is the second? He has given Young's modulus. Young's modulus. What is the definition of Young's modulus? Stress by strain. From the previous classes, stress by strain. What is stress? Force by area. What is strain? Change in length to the original length. Change in length to the original length. Observe this. Denominator strain, that is change in length to the original length, length cancels. There is no dimension formula for it. So only you have the numerator, the dimension formula. That means the Young's modulus have force by area dimension formula. What is simplification? The same as in the previous class. M, L minus 1, T minus 2. That means pressure, Young's modulus have the same dimension formula. And third thing, he says that stress. What is the stress? Force by area. Again, this is also having the same dimension formula. All the three. Pressure, Young's modulus, force by area, stress, all have the similar dimension formula. Hence, this is not a correct option. Clear? Now, let us go to the second option. Let us check up the second one. The second option he has given heat and work done. And the third one he has provided is energy. All are having the same dimension formula. Heat is one kind of energy. Work is the force into distance, and the energy. All are having the same. So that is ML square T minus same. All are having the same dimension formula. Clear? So this is also not a correct option. Okay. Now let us check up the third one. Third one is C. EMF potential difference and electric potential. All are same quantities. Electromotive force or potential difference voltage or electrical potential, all are having the same dimension formulae. Hence, this is also not a correct option. Let us check up the fourth one, that is electric dipole moment. What is electric dipole moment? It is simply defined as torque by the electric field. Electric field. And electric flux. What is electric flux? This is electric field into area. And third one is electric field. What is electrical field? Electrical field is electric force for the charge Q. Observe these three things. If you observe these three things, electric field is electric force per charge, and electric flux is electric field into area. Okay, and electric dipole moment is torque by electrical field. So one is dependent on the other. So all of them have different dimension formula. Since by simple mere observation, we can easily find out all have different dimension formula. There is no need to find out the dimension formula of each quantity. Just observation only gives us the clue. Clear? So this is the correct option for the above question. Clear? Hope you have understood the lecture. If you like, please subscribe the channel. Thank you for watching.